Kia ora Year 12. I hope your Saturday nights have been just as trig-filled as mine has. Here's a second video. This one's looking at the later part of Mr. Hurring's worksheet, and I've added in my own bit here, which I think you'll like more than what you've got to do in this question. Right, so first of all, we have to verify that the following pairs of functions are equal, but we have to do that first by examining the features of the graphs of each function, right? So we're not going to use our brains and do a proof just yet. But that's going to be the second part, the extra part that I make you guys do. Okay, so the first thing we're going to do is we're going to look at this function and we're going to figure out the features. So period, amplitude, vertical and horizontal shift. Right, so this time we're going from the equation to the features. And then we're going to look at this, but we're going to look at that by chucking it into either our graphics calculator, which is what you'll need to be using if you had something like this in the internal, or at home, you can do it on Desmos. So I've done it on Desmos down here, right? So what we're going to do here is this is going to be pretty easy. And then this is also going to be easy, but we're going to use this method where we get the coordinates of these points. And from there, we work out the period, the amplitude, the vertical, and the horizontal shift, right? And we're going to work those out, and then we're going to go, oh, look, they're exactly the same as the ones for that one there. What a surprise. And then finally, we're going to do a proof to show that that is equal to that. Okay, so let's get on with it because it is already 10 o'clock on Saturday night. Right, so y is equal to 3 cos of 4x minus 2. Okay, this should really be feeling fast now. It would be feeling better if OneNote hadn't disappeared on me. Come on, OneNote, where are you? Right. Okay, so 3 cos of 4x minus 2. Right, so the amplitude is 3. The vertical shift is 2 units down. Now, what else? Well, we've got no horizontal shift, right? Because we've got 4, this is 4 times x plus 0. And the 4x means that the frequency is 4, right? So I think you've got to be really careful that you've got the difference between the frequency and the period. Frequency of 4x means that the period is much shorter than usual. So the period is the normal one, 2 pi, divided by 4, which is pi on 2. Now, if you're not sure about that, grab your graphics calculator and just check that you can see what's going on there. Everything in here is getting sped up, right? The x values are getting sped up relative to the normal cosine function. Okay, so I think that's everything done for that. Yep. So period, amplitude, vertical and horizontal shift. Now what we've got to do is we've got to take this thing here and chuck it in our calculator and look at the coordinates. So I've done that here using Desmos. Obviously, you're not going to be doing screenshots of things if you did have to do this in test conditions. So what you could do instead is you just draw out that. That looks terrible there. Let's put the coordinates of this point on, the coordinates of this point, and the coordinates of this point, just like we did on the earlier part of this worksheet. So there's 0, 1. Here's negative 0.7854. negative 5, and here's negative 1.5708, which should look familiar, and this. So again, the way that I've got those coordinates is that I've put into my calculator the function that we're not able to read the features off straight away, right? So we're using the coordinates to do it. Right, now what we have to show what we're doing here. So the period for this function is 0 minus negative 1.5708, which is 1.5708, which is pi on 2. That means the frequency, you don't really have to do this one, but you might as well, is 2 pi over pi on 2, which is 4. Next, we're going to look at the vertical shift and the amplitude. Right, so my vertical shift is going to be halfway between those two numbers. So it's y max minus y min, so it's the midpoint of those two. So it's 1 plus negative 5 over 2, which is negative 4 over 2, which gives me negative 2. So 2 units down. There's no horizontal shift, right? And so that's because the maximum is at x equals 0. So there's no horizontal shift for a cosine model. And you might just want to pop in a tiny wee sketch of our cosine curve. There we go. Right, so it looks like that. So features are all the same. As 3 cos of 4x minus 2. So we can say that those two functions are always going to be the same. Now let's get to the more fun part, which is how we can prove that those two things are the same. Well, if you take a look at that, it's not immediately obvious whether it's better to start on the left-hand side or the right-hand side. But I'm going to start, I think it is definitely easier to start here. I know someone's about to send me an email saying that they did it the other way around. The reason I'm going to start here is when I see that 4x, I see a double angle formula. And you know how much I like the double angle formulae for cosine. So let's get going, always keeping an eye on where we're trying to get to, right? So we want to end up with, we've got cosine of 4x, but we want to end up with stuff with just cosine of x's in it. So let's do that. We've got 3 left-hand side, 3 cos of 4x minus 2, which is equal to 3 cos of 2 times 2x minus 2. So I've got a double angle, but it's a double angle with 2x. And I'm heading for just cosine curves, so it's going to be 3 times 2 cosine squared of 2x, not x, minus 1, minus 2. Now, by this point in the topic, when we're getting this close to the assessment, you guys shouldn't need your formula sheet for these double angle formulae, but you will get them in the assessment, right? But this one here is one that you should really know by now. So cosine of 2x is equal to 2 cos squared of x minus 1. Okay, what do I do now? Well, I'm going to clean up the constants in there. So I've got 6 cosine squared of 2x minus 3 minus 2, so minus 5. And that's equal to this. It's 6 times cos of 2x times cos of 2x minus 5. So let's do the easy double angle on both of those, and we're just about there. But don't hang up the video, okay, or whatever. Don't turn off the video. Right, so we've got those ones. Now let's expand this out, and you can see that we're nearly there. Remember where I'm trying to get to is back to here, right? So I'm trying to get to 24, blah, blah, blah. And you can see the 24 starting to fall out. But let's remember it's a show that question, so going nice and slowly. So 4 cos to the power of 4x minus 4 cos squared x plus 1 minus 5. And look, we are done. We've got 24 cos to the power of 4x minus 24 cos squared x plus 6 minus 5. Didn't really need to do it that slowly, but we can. And then I think we've got it in factorized form to start with. So let's get it exactly how it looks. So there you go. So that is now equal to the right-hand side as required. So just going over the logic here, what we've done is the first thing we've done is this kind of artificial thing that says we've got features for that we can look at graphically, and we've got features for that we can look at graphically. And if those features are exactly the same, that means that we know that those two functions are the same. But it's kind of unsatisfying because we don't really know why they're the same, right? So when we do the proof, we're showing that that works. Okay, thanks for watching. There are some quite good problems in those last 4. So if you're getting stuck on them, I'm not going to post solutions just yet, but have a go. And if you're desperate, email me and I can video the answers for you.